Hello, and welcome to Engineer Speak. Tonight's event is brought to you by the American Society of Mechanical Engineers. I am Francis Fish, President of the University of Delaware chapter of ASME. Tonight our guest speaker is Brittany Russo. Some background about Ms. Russo. Brittany Russo graduated from UD in 2008 with a bachelor's in mechanical engineering. She earned an MBA from Villanova in 2014. She is currently a project engineer at Breskem, where she manages the site's capital projects. She started her career with Sunoco as an engineering associate and rotated through various divisions and then secured a permanent assignment as a reliability engineer in Breskem's maintenance and reliability organization. She has held that from 2009 to 2013 and then transferred to her current role in Capital Investment Group in the early part of 2014. Ms. Russo is here tonight to talk about the polypropylene manufacturing process with an emphasis on rotating and fixed equipment used in the process and the role of a maintenance and reliability engineer. I would now like to hand the podium over to Ms. Brittany Russo.
All right, how's everyone doing tonight? Good?
How are you? Too shabby.
Well, thank you. Thank you for having me here tonight. I'm very excited to be here and talk about my career experience thus far and about the wonderful company I work for, Breskem. Before I even get into my career, which Francis kind of already touched on, I want to let you guys know that I am a fellow Blue Hen. I graduated here in 2008. And I met my now husband here, who is also a mechanical engineer. Fancy that. So I have a special place in my heart for UD, and I know a lot of people have probably said it to you, but time goes fast. Really enjoy yourself. Make sure you're taking full advantage of the different organizations you have on campus, the different networks you have, because they can really help you grow your skills in a multitude of ways. So with that being said, like Francis touched on, I did start my career with Sunoco through a engineering rotational program. Many companies these days have rotational programs. One reason I liked the rotational program, and you may be experiencing the same feeling now, I wasn't exactly sure what I wanted to do, even though I came out with this degree in mechanical engineering. And what's also funny is that one of the reasons I chose mechanical engineering, and it says it right out on one of your billboards outside here, is it's the liberal arts of engineering, right? It's very broad. I knew I liked math and science. Mechanical engineering opens an enormous amount of doors for you in many different industries, many different types of jobs. So you definitely, I think, are putting yourself in a good position by earning a mechanical engineering degree. So with that said, I started with Sunoco. I actually worked as what they call a retail engineer, dealing with the actual service stations. I never thought I would be helping with the engineering details of a gas station right out of college, but that was actually pretty interesting. And then from there, I went down to Houston, Texas, and I entered the chemicals division of Sunoco. And there is where I kind of got my feet wet in the manufacturing world and really, really enjoyed it. So with that said, I'm going to talk to you guys about Breskem and what we do, who we are. And at the end, I'll leave time for some questions, but feel free to interrupt me anytime. This is very casual, very informal. So the petrochemical industry in general. When you look at the petrochemical industry, you have what's called the upstream side, where you're actually extracting the crude oil, the crude products, right, from the earth. And then if you go all the way down to the other side, you end up, our company's calling it the third generation of plastics, but your finished products, which in Braskem we make PE polyethylene, PP polypropylene, and PVC polyvinyl chloride. So we actually get propylene, and then we further refine it. We use what are called splitters to split propane and propylene. We sell off the propane, we don't use that in our process, and the propylene we convert into polypropylene. Our finished product is a small plastic pellet that then gets sold to many different suppliers who then use thermoformers, injection molders, things of that nature to turn it into, and extruders, other things to turn it into cups, diapers, carpet backings, automotive plastics, medical sutures. There's really nothing that our plastic doesn't go into. A lot of you may be familiar with Chobani Greek yogurt or the sole supplier for Chobani's Greek yogurt cups. Sterilite, a lot of the different plastic containers you probably use to move your belongings to and from campus each semester. We supply the plastic to those types of companies. Okay, so I kind of already touched on this, but basically in America, we're on the polyolefin side, and like I said, we specifically make polypropylene in the US. In Brazil, and I'll touch on where we are located throughout the world, we also make polyethylene. We also, which is very cool, we're very proud of this. In fact, I'm jumping the gun here, but I heard your materials science professor actually called out our company in class because we are the first company to create green PE, polyethylene from sugarcane, which I'll touch on a little bit later. Okay, so where are we located? When you look around the world, we have facilities, manufacturing facilities in the US, we have them in South America, and then we have them in Europe. In the US specifically, we have 5 manufacturing facilities. We have 3 in Texas, 1 in PA, and 1 in West Virginia. We also have our corporate headquarters in Mellon Bank Center, which is in downtown Philadelphia. In Germany, we have 2 plants. They're both polypropylene plants. And then in Brazil, we have too many for me to name, but we have a lot of manufacturing sites in Brazil. And if you haven't figured it out, Breskem is a Brazilian company. All right. So commercial footprint, this is a list of all of our commercial offices globally. All right, so like I already mentioned, our headquarters are in Philadelphia, PA. The closest plant, which is really only about 30 miles from here, it's the one I work at. It's in Delaware County, Marcus Hook, Pennsylvania. Marcus Hook General is an industrial area. There's a lot of different industrial companies located within that surrounding area. We also have a research and technology and R&D center in Pittsburgh. And then, as I mentioned, in West Virginia, which is the next closest site to here, we have a manufacturing facility, and 3 along the ship channel right on the Gulf in Texas. Okay, so what does our plastic go into? I kind of touched on this earlier. When you look at what our plastic goes into from a global perspective, it mainly goes into food packaging. But in the US specifically, we really make a lot of plastic for food packaging. We make a lot of films as well. And then we also make a lot of products that go into hygiene and cleaning. So this is everything from, like I mentioned before, specialty products such as diapers, feminine products, things of that nature. And then we have a big niche in the US, specifically in our Texas sites, that make a lot of specialty automotive plastics. And those, we really get a high margin from those plastics because they have to have a unique set of properties to be able to handle things such as heat. You know, your car dashboard in the summer can experience temperatures, over 120 degrees. So those plastics need to have special properties so that they don't break down in extreme heat or cold. All right, Breskem looking at numbers, and this is 2014 numbers, so it probably has even changed a little bit since then. In terms of team members, you can see we have about 8,000 team members worldwide. We have clients in over 70 countries. In 2014, we also had 22 billion in gross revenue, and EBITDA, which is earnings before interest, tax, depreciation, and amortization, of 2.2 billion. Our company is very big on EBITDA. That's one of the main focal points when we look at the health of the company. So when we look at the history, I'm not going to go through all of this, but what I really want you to take away from here is that Breskem is a newer company. We were actually established in 2002, so we're only in our 13th year, but we have strong backing from Odebrecht, who's been around since 1978, 1979. So future slides go into this, but both Odebrecht and then Petrobras, which is the large Brazilian petrochemical manufacturer, is the primary shareholders of the company. So in 2002, Breskem was formed. As time goes on, they start scooping up other plants. That includes the Sunoco plants that are located in Philly, near West Virginia, and Texas, scooping up some Dow plants. The ones in Germany were formerly Dow plants. And in 2015, like I said, we have 5 sites in the US, 2 in Germany, and we're continually looking to go through mergers and acquisitions to be the biggest petrochemical company, plastics company in the world. Okay, so I'm not going to get too much into this, but as I just mentioned, Odebrecht, which is a very large construction company, and Petrobras, they are the main shareholders of Breskem. So a lot of their principles, including what we call TEO, the Odebrecht Entrepreneurial Technology, stems from Norberto Odebrecht, who was the founder of Odebrecht. When you join Breskem, you get an immense amount of cultural training, and we really value our culture because we think our culture is something that sets us apart when you look at other corporations and organizations throughout the world. We really believe in our people. We understand that people are our biggest asset, and some of our main values and guiding principles stem from making sure that we have a spirit to serve. That's why you'll see there, serving the client. We really have a spirit to serve not only our fellow colleagues, but also our clients. So we're very mobile and adaptable. These are some of our guiding principles. You know, in the manufacturing world, you kind of have to be mobile and adaptable, right? Especially if you're a 24/7 hour operation. Things are not always going to go smoothly. You're going to hit roadblocks, you're going to hit obstacles, just as some of you who may be seniors in your and are going through your senior design project, you may have already been experiencing some of that, or have been throughout your past 4 years here. So you have to be mobile and adaptable, especially as things change. Industry changes, processes and systems are constantly updated. You're always looking for the next best practice or best principle. Your textbooks change almost yearly, right? But we all know that's just for the companies to make more money. Anyway, my point is, things are constantly changing, and you have to be able to be adaptable and move into that, and Breskem really values that. We also really believe in education through work. So you're here to get a bachelor's of science in 4 years, but that's not to say when you enter the corporate world that you're going to stop learning or that that's the end. And Breskem really values making sure that people are getting educational opportunities to grow themselves professionally and personally while in the workplace. We do offer and believe in additional training outside of the workplace too, to help grow your professional skills, but we also want to make sure you're getting opportunities within the workplace to be able to grow. So that's another thing we value. We also value being innovative and creative. And as a mechanical engineer, you certainly are going to have to be innovative and creative. You're always looking for ways to improve. You're looking for new designs, better designs, things of that nature. So we really want people and value people that are able to be creative, that are able to think outside the box. It's a term we've all heard all the time, right? And I forget what class I took here, but no idea is a bad idea. Everything goes onto the table, and then you can cross it off as you identify ideas that are better and can justify the reasons why. But we really value people's opinions and ideas, and we want people to be innovative and creative because that's what makes you better. That's what makes you grow. Okay, so I'm going to move right into renewable chemistry. We already touched on this, but basically we're very much into our research and technology sector of looking for ways to grow within the renewable chemistry field. Like I mentioned, we are a world leader in biopolymers, and we are the first petrochemical company to make plastic from sugarcane. And I actually got to visit this site shortly after it was commissioned in September 2010 in Brazil. And it was pretty amazing, and you could tell that people were very proud there to be able to offer plastic from a renewable source. And you can see the investment in that was $290 million, so no small sum of money there. And it's still doing great today, and it's a growing field, and our clients are realizing the value of using renewable plastic, and they are paying more to use renewable plastic. And I think we're going to see as time goes on, those types of products that consider renewable sources and renewable energies are only going to grow, right? So it's a pretty amazing feat for us. I'm not going to get into all the different projects and whatnot that Breskem is involved in, but I just want you to know that we do realize we have a social responsibility to the communities we operate in, to the local government, to the federal government, and to the world, really. And we make sure that we're constantly looking for ways to minimize our carbon footprint, and that can be in terms of reducing our energy consumption to operate our plant, looking for ways to improve our yields, yet use the same amount of product or same amount of energy. So there's a lot of different ways you can do that, but we are committed to being, a socially responsible partner within our communities and really within the world. So I touched on this already, but basically our gross revenue was $22 billion in 2014, and it boiled down to an EBITDA of $2.2 billion. You guys should also know that we were voted one of the top places to work by Philly.com in 2014. And although we were not the largest company, we're still pretty sizable within the US. I think we have over 600 or 650 team members in the US. And we really have the mindset of a small firm, even though we're about a medium-sized firm here in the US, and a large firm if you look at it from a global perspective. So we were really happy to achieve this. And I think it's really because, and I'll kind of touch on my personal experience, having switched from one company to another, but we really give you a lot of responsibility early on, and that is true of our associate engineers, people coming right from undergrad and entering into the workplace. And we realize you're hungry, you're eager when you get out of school, you want to make a difference, both personally and maybe, hopefully, make a difference to make the world a better place. And we really value that. We give people a lot of autonomy, so we allow you to do things the way you feel that it should be done best. And we like to share best practices, and we like to look for ways to continuously and constantly improve. And I will tell you that even the associate engineers, they have a lot of responsibility, and some of them are responsible for projects that are pretty extensive, pretty sizable in terms of the amount of funding that goes into them. And we really entrust all of our team members to contribute and to add value to the team. And it doesn't matter if you've been out of school for 6 months or you've been with the company for 30 years. So let's talk about the associate program, because that's mainly what we recruit for. We recruit both engineering and business students, but engineering is kind of our backbone, especially when it comes to chemical engineers, mechanical engineers, and electrical engineers. But basically, our associate program, it's a 2-year program, 24 months. You do 2 12-month rotations. We do consider your geographic preference. So if for whatever reason you were not interested in going to Texas, we take that into consideration. And we used to make you do one rotation that was geographically diverse from wherever you came from. We don't do that anymore. We tend to find that people will stay with us if they enjoy the place where they live, right? It makes a lot of sense. So anyway, but you have the opportunity to go to our different locations throughout the U.S. And even recently, within the last year, we made this program a global one. So students have actually got to do 2 to 6 month rotations in Brazil, which I think is awesome. They all come back fluent in Portuguese and have a wonderful time. So we basically are going to give you one main project to focus on, right? So something that you can show results for at the end of your rotation. And we have you present your idea to the business committee. So this is our VP of manufacturing and his leadership team. And You present that idea, and it's approved by the leadership team, and then you work to actually implement that project throughout the course of the year. Now, that's not to say that's the only thing you're working on. It's just kind of your main focus for that yearly rotation. But during that time, you're getting exposure to plant life if you're in the plant, and you'll be helping out with other daily tasks and issues that come up. And then you also get a lot of great onboarding training your first year. And I think the next slide goes into some of those types of training. So in your first year, you get to go to all the sites in the US, which is pretty amazing. I didn't have that same opportunity when I was in the associate program. It's really changed quite dramatically, and in my opinion, in a very positive way. So you get interpersonal skills training, and yes, I know that you've been dealing with people, you've been dealing with teamwork, right? And throughout all your courses, they're really going to emphasize teamwork, because when you enter that corporate world or when you enter that manufacturing world, that doesn't change. You're still going to work in teams. You're still going to have issues from time to time. Everyone's different. People work differently. And you have to learn how to work with people that are different from you, and be able to share common goals and get to an end solution. So that's kind of what that training center is around. We also give all our engineers Six Sigma training right away. Six Sigma is not new. I'm sure you guys have all heard of it in here, and I'm not sure if they offer courses in Six Sigma here, but that's something we do right off the cusp. And then we give you presentation skills training. And again, I know you guys have had to get up in front of audiences and present, but it's just kind of a deeper level of presentation skills, especially when you're in front of not only your colleagues, but also people on the leadership team. It teaches you kind of how to talk and present the things that they would want to see and listen to. So we really have a strong focus on training and development. I'll get into specifically, I brought some handouts on the different rotational assignments that were available in 2015 to give you a flavor of what those include. But depending on what your role is, and being mechanical engineers, most who have mechanical engineering degrees tend to lean into wanting to be a mechanical reliability engineer, which is one of the main roles within the plant. And if there's special skills you want around, let's say, vibration training, to be able to do vibration analysis on equipment, we offer that, or we would support that. Oil analysis, to be able, and this is all to be able to understand the health of the machinery, right? If you want thermography training, you want to learn how to detect equipment issues by looking at different temperature patterns and whatnot, we offer that. Now, I've actually gone through all that training, and so some of the things that you learn in school, you get to build upon them, and there's some things, at least in my personal experience, I didn't learn in school that I had the opportunity then to go into a manufacturing environment and get additional training and learn about. All the concepts were there, but I got to enter into new fields that I hadn't had exposure to yet while on undergrad.
Question?
Sure.
Those specific trainings you were mentioning, the vibrational and then the oil
Analysis, yeah.
oil analysis, are those formal trainings or is that on site? Like, are you put on a team that does that normally, and you just kind of learn on the job, or are those formal classes?
So they are formal classes, and typically they are off-site, taught by a third-party organization. If the interest is big enough, sometimes we'll bring those third parties in-house and have a host of 10 engineers from all the different sites in one room. We do have a nice matrix put together for, say, mechanical engineering. I don't have it on me right now, but basically it's this nice matrix of describing what trainings you should have to be in a mechanical reliability role, both in years 1 to 3, then 3 to 5, and then 5+ we start considering you a subject matter expert, or going into deeper trainings, or level 2s and 3s of, say, vibration analysis, oil analysis, things like that. So it can be either, but typically the training itself is given by a third party. So some of the projects that have been worked on in the past are creating a real-time scheduling tool to better manage the olefin supply to the Breskem America plants. That is on the commercial side. That would be a business project. Okay. Then people and organization, P&O, that's what you guys may have heard of, may more commonly heard as HR or human resources. We do hire P&O associates. So one associate worked on a project to attract and retain team members. This would be a process or production engineer, and this would be a project for them, reducing wide spec products, so product that's not meeting our specification for some reason, the way we're running it, or how we're inputting all of the raw materials is not producing the plastic that gets us that top dollar or top margin. So their project was to reduce wide spec product at a particular plant, saving Breskem $100,000 per year. And then this one, I know the engineer that worked on this is basically improving our cooling tower pump reliability, and this is something very real for a mechanical reliability engineer. So as I mentioned before, we recruit for business and engineering students, and in business rotations for 2015, this changes sometimes. There's many different organizations within the business unit, but specifically 2015, we were looking for someone for our people and organization department and our procurement department. And then in engineering, we have process and production engineering, mechanical engineering, and electrical engineering. And every plant has at least one process, one production, one mechanical, and one electrical. And usually we have at least two per site. And as I mentioned before, there's a recap of where we're located in the U.S. So, unfortunately, these two slides don't give the highlights of what a mechanical engineer does. So I'm just going to get right into that because that's, I would think, what you're most interested in. There's two mechanical engineering associates that I've worked with in the past. The first assignment for a mechanical engineer was to work under what's called the level 1 reliability engineer at the site. That was the role that I was in. The level 1 handles all the day-to-day issues that come up in the plant and does the first troubleshooting, kind of the first responder if equipment goes down. And I'm going to touch on what types of equipment you can find in our industrial plant after this. But they also are in charge of putting together preventative maintenance plans and predictive maintenance plans. The predictive maintenance is kind of what we were talking about before, that oil analysis, thermography, basically non-intrusive types of testing to be able to determine the health and integrity of the equipment. They're also responsible for looking for improvement opportunities, whether they be capital in nature, they require enough funding that it's actually turned into a capital project, or smaller improvement opportunities that maybe are expense items, but will add a lot of value or decrease cost to operate a piece of equipment or to improve yield overall. So the first rotation this associate did was mechanical reliability engineer under the supervision of the level 1 mechanical reliability engineer. The second rotation was in capital projects. He was a capital projects engineer under the capital investment group, and that's the group I work under now. So he was basically given a slew of projects that could be chemical in nature, electrical in nature, and working with those engineers to implement those projects. A lot of them, 9 times out of 10, still have mechanical attributes, so there's still things that mechanically need to be addressed, designed, and details worked out, but you get a little bit more exposure as a capital projects engineer to chemical engineering, to electrical engineering, and you tend to get to work with a little bit more money when you're a capital projects engineer, which is kind of cool. This is a picture of our, let's see, I don't know who, 1 or 2 of these guys went to UD. Actually, I don't think he's an engineer, but Terrence Chin Young, I think he was IT. He went to UD. Trying to see if there was anyone else here that went to UD. I think that may be it for that class. But we do actively recruit, and we've got good engineers and business associates from UD. So what does it take to be able to work for us? We're typically looking for graduates that have a GPA of 3.0 or higher. We're really looking for someone that knows how to communicate well, and that's able to work effectively in a team environment, right? These should all not be new terms to you. You've probably heard them quite a bit over the last 4 years here. We want someone that can demonstrate leadership skills and has the ability to lead a team or to lead a project and isn't afraid to speak up and speak out when you have an idea or an improvement opportunity, or quite frankly, if you don't agree with someone else's idea or you think there's a better way to do it, to have the courage to be able to speak up and let your idea be heard and known. We want someone who can embrace and manage change effectively. Like I mentioned before, one of our core and guiding principles is being mobile and adaptable. And no matter what, if you do decide to go into the manufacturing industry, which I think is a very exciting industry, I think it's very cool to make things in general. And we typically have a lot of mechanical equipment in a manufacturing facility. So being in that environment, you're going to face change all of the time. It's just inevitable. And so knowing how to deal with that change and how to respond to it and how to be able to formulate solutions if an issue arises, that's really important, and that's something we value. And then you have to have the ability to work in the U.S. without any company sponsorship. So here is our website, and I will give this presentation to Francis so that if you guys are interested in learning more about us, you have the web links here to be able to get to that. One thing I want to point out is that Odebrecht sponsors a contest every year where it's open to any engineering discipline, any person that's at an accredited university taking any kind of engineering course or construction course that's working on a project that furthers sustainable development. Very broad, but anything within the sustainable realm, they offer a contest you can actually enter into and get cash prizes. And who doesn't love cash, especially when you're a student and are trying to buy $150, $200 textbooks. So again, this is in the PowerPoint, and if you're interested, I think the deadline's up for this year, but this is an annual contest, so it's something to consider because I know you guys are involved with other organizations where you're entering into contests and things like that, so keep that in mind. And that really is the end of my presentation. The last thing I want to do before I open it up to other questions, I want to pass out these associate rotation pamphlets from 2015, so I guess if you could just pass those out. I didn't get to elaborate heavily on what a mechanical reliability engineer does, so I wanted to show you the job description and see if you guys had any more questions about what a mechanical reliability engineer does. One thing I'll point out is in school you're doing a lot of calculations and you're reading a lot about different types of equipment, whether it be a compressor, a pump, a turbine, a fan, you need a chiller, but I'll be the first to admit that the types of compressors, knowing the different types of compressors that exist and all the parts in them, I was lacking in that realm until I got to the manufacturing world. And I'm not saying that that's for everyone. Some engineers are going to go through most of their life without having exposure to different types of compressors or pumps. It just depends where you land, what field you land in, and what you want to do. But one thing that having the engineering backbone gave me was the ability to understand conceptually what's going on inside the machines, to better troubleshoot and to better help improve the machine's capabilities. But being in the field and getting the exposure to actually touch the machine, be hands-on with the machine, that's what I found that I really enjoy. And I do like the ability to not sit at a desk all day. I knew that I didn't want to be a design engineer or someone that just crunches, and when I say just crunches calculations, give those people a lot of credit, and obviously you need to do your due diligence around making sure that your design is complete, thorough, and that it's going to work. But what I like about the manufacturing role is that you get to apply it in a more in a different way, where you actually are out in the field, working with the equipment, working with mechanics, working with I&E techs to help troubleshoot and make the equipment better. So, what I say about my job, both my former job and even now so, but definitely more so in the mechanical reliability role, was no 2 days are ever alike, right? On a good day, and when I say good day, that means everything's running really smoothly. And that's where you can go catch up on things at your desk. But when things aren't going smoothly, if a compressor shuts down, you have to find out why, right? And being in that role, you kind of get to be that first responder, you get to be that troubleshooter, and you get to figure out, well, do I need to just go out first if the equipment doesn't have its own condition monitoring system, if it doesn't have temperature sensors at each valve to know what's going on? Should I go out and take temperature readings on the different valve locations to see if there's a bad valve? Or, is the packing leaking within the machine? These are all the things that you get to do on, I don't want to say a daily basis, but it's not uncommon to go have to respond to a machine that's down, or help push for a capital project to make the machine better. So within the petrochemical industry, specifically the polypropylene manufacturing site, you'll find compressors, both rotary vane compressors, reciprocating compressors, and also centrifugal compressors. You'll find all different types of pumps, from positive displacement pumps to centrifugal pumps. You'll find specialty equipment meant for handling resins and powder. So that could be screw conveyors, ribbon blenders. Our largest machine, kind of what I would consider the heart of our site, is our extruder. It's a large twin screw extruder. It has a 350 millimeter barrel on it, so it's pretty large. Not the largest in the US, but it's a very large machine. And that's actually what takes our resin, heats it up, makes it molten, turns it into a liquid, and then it goes through a die plate where what we call pelletizer cuts it underwater, so that plastic instantly freezes when it makes contact with the water, and turns it into this tiny little plastic pellet. And so, just looking at that extruder machine alone, there's a lot of improvement opportunities over that extruder machine that we're constantly looking at and constantly evaluating, and see if it makes sense from a business perspective to put money into the machine to be able to run faster rates or run different types of products, things of that nature. So you're really dealing with a lot of different types of equipment within the polypropylene industry, and after having underwent 4 years of schooling, it's nice to be able to see these things out in the field and get a different education that you may not have experienced while sitting in the classroom. So with that said, I'll open it up. I don't know if any of you had a chance to kind of skim over the position, or if you had any questions for me in general. I'm all yours and open. So.
At this point, let's give our speaker a hand. All right, so this now begins the directed question portion. Don't worry, it's going to be pretty short. So, we've got time to muster up the questions. All right. Well, you mentioned communication quite a bit during your presentation. What is some advice you would have for someone in college or fresh out of college?
Yeah. So I know that my communication skills, they weren't the best before college. I could communicate, but not as clearly as I can today, and that will grow over time and with experience. Just as you grow older, hopefully you'll become a better communicator. But one thing that really helped me, believe it or not, when I was in school is I actually was a Blue Hen ambassador, a tour guide. So I was put in a position where I had to be in front of 20 to 30 people at a time and be able to convey facts and figures, field questions on the spot. And that actually, to be quite honest, helped me become a better communicator. I was doing it often enough where it became kind of second nature to take on questions, spontaneously and be able to answer them and to be able to effectively communicate. It also helps you realize you don't think about this necessarily when you're speaking, but how are you speaking? Are you speaking confidently? Are you yelling? Are you talking softly? People, you'll naturally form perceptions about people based on how they speak and what their demeanor is like. If I was standing over, up here slumped over like this, talking very quietly, you probably would think I'm a timid person, and you may not want to work with me because you're not necessarily sure I can effectively communicate to you or other team members. So the biggest piece of advice I can give you is try to put yourself in what you consider uncomfortable situations, or situations that aren't second nature to you, and try to grow your skills. And you're naturally doing that through your classes and the different presentations that you have to give to get a grade, to get hopefully a good grade in your classes. But try to find other outlets also that can help you grow your skills, whether it's through ASME. I don't know if you guys do roundtables or you come up here and talk about different projects or things you're working on. But try to find outlets and practice, especially if you aren't confident being in front of people. Practice by yourself in front of the mirror, I know you've heard it, or practice with a friend who can give you that candid feedback. Practice with your professors, or when you go in for your meetings and your advisor situations. If you have specific questions, they all are obviously very well versed in being in front of large groups of people. They've done it for longer than most of us, to be quite frank, have been alive. So use them as a guide. If there's someone that you really like who you think speaks very well and is very captivating in front of an audience, go and talk to them and say, can you give me some pointers, or observe them and observe what they're doing and try to mimic that or replicate that when you're up presenting. So that's the advice I would give.
Professor Keefe was chuckling in the back there.
And that other old round guy, the other old white-haired guy.
All right. How did you pick your first job?
Yeah, so I had all my first round interviews here on campus, and I actually had 6 job offers coming out. I think I was also in a different time where the job market was still pretty hot. It was pretty easy, and not that it's too difficult for you guys now, but I was fortunate enough to get a number of different job offers, and I think I mentioned this earlier on, or at least alluded to it, was that I wasn't exactly sure what I wanted to do. So a rotational program was very attractive to me because it allowed me to get my feet wet in different areas. So the reason that I picked the job I picked was because it afforded me the opportunity to be able to rotate throughout different divisions of the company and allowed me to try different things. And then I ultimately discovered that I love manufacturing. I just love being in the manufacturing environment, and the rest is history. Have been in it now for almost 7 years, so.
Okay. They get deeper now, these questions.
Not too deep, I hope.
What has been your greatest struggle in your engineering career?
That's a good one. Greatest struggle. So, I guess one of the main struggles, and I wouldn't say that it's as much of a struggle anymore, but I would say one of the main struggles when I first entered into my career was being able to gain the trust and gain the, I won't call it respect because I was always respected per se, but getting people to understand that you are capable of doing what is asked of you and then beyond. So I think a lot of times, you're going to work with people that may have 30, 40, sometimes 50 years experience over what you have, especially if you're brand new in the industry. So it's very important early on to make sure that you're putting in the work putting forth a good work ethic, and that you are also reaching for things to do, that you're showing the initiative to be able to take on new responsibilities, take on new projects, and then finish them. Not only take them on, but finish them. Get results, get positive results, and also then being able to convey those results, and then being able to continuously monitor those results, right? That's what you learn in Six Sigma, is to be able to go back and monitor the improvements you've made to make sure that they are still improvements and that you're still creating a positive effect. So I think for me the biggest struggle was getting people to trust me, and not because I acted a certain way or put forth a certain demeanor, but I just think when you come out of school, people know that you don't have as much real world experience. Hopefully you've had one, maybe two internships if you're lucky. So you really want to make sure that you are showing that you are willing to take on responsibility, and that you are also working to be an effective communicator, right? Because you're learning all these new things at once, all new processes and systems of the organization you're in. You're interfacing with all these new people. So learning how to effectively communicate within the organization based on that company's culture, I think is really important. And it's something that I think was a bit of a struggle for me first entering into making that transition from academia into a corporate environment.
All right, now the flip side of that coin, what was your proudest moment ever in your career?
Ooh, all right. Well, that's
Granted, you still have a long career
Yeah,
ahead of you.
yeah. We're all probably working till we're 85, by the way, but that's another story. The proudest moment in my career, I think the proudest moment is when the plant manager, who's now the plant manager of the facility that I work at in Marcus Hook, he used to be the production superintendent down in LaPorte, Texas, where I worked as an associate engineer. When he came up and first took on the plant management role, we were having a roundtable, and he was sharing his past experiences at LaPorte, and then he spoke about me, and he basically said, how much of a go-getter and hard worker I was, even though I'd only been with the company for a year, and elaborated on the types of projects I worked on and how I worked well with people. And to me, that was a really proud moment for me, because he recognized, even though he was in a management level, and I didn't even work for him, and I wasn't even in his department, he recognized, my passion for trying to contribute and trying to make a difference, even though I wasn't in a managerial position, and even though I didn't know everything there was to know about the company. And you'll never know everything, right? But him recognizing that I was trying to make a difference, to me, was one of the proudest moments that I've had yet in my career, to be honest, yeah.
Okay. With that, we'll open it up to audience questions.
Does Breskem have any kind of internship program?
So we're working on a formal internship program as of right now. We're hoping to roll it out this summer. I'm actually, unfortunately, going to turn this one over to Matt as well, because Matt interned with us last summer. But we don't have a formal program right now. I'm hoping that by this summer, we'll be here in another month or two to be interviewing for internships. If we don't have one this summer, we'll definitely have one by next summer for sure. We're a little bit behind the game in our internship program. But if you are interested in interning with us, I can give Francis my contact information. If you have a resume, you can certainly send it over to me, and I could forward it to our HR department, for consideration. So keep that in mind.
So about the internship program, so last time I worked as a reliability and engineering intern, I was mostly helping out with taking a look at all these maintenance procedures that we had for the plant, and just going through and figuring out what drives it, what safety reasons do we have, and how does it affect the company itself. So that was more the desk side of what I did, and then I would also have time to go out in the plant, learn safety procedures, and like get involved on a few work orders to try and just get experience and understand some of the technology and stuff we had in the plant. So you have time where you're working behind the desk, but you also do get the opportunity to go out in the plant and get experience to help develop your skills.
Was that Marcus Hook or?
Yes, I was working at the Marcus Hook plant.
And just so you guys know, even though your degree's in mechanical engineering, if for whatever reason you were interested in production engineering or even electrical engineering, Breskem just tries to hire the best of the best. We think that if you have a good analytical mind, you can learn the rest. So we've had engineers, we've had chemical engineers that have tried maintenance and reliability out. We've had chemical engineers that have gone right into business positions and roles because that's what they were interested in. We've had, engineers go into things that aren't necessarily what their degree you would expect them to go into based on their degree. So keep that in mind. And as Matt was saying, the plant roles are definitely roles where you're not sitting at a desk all day, which is what I enjoy. I would go stir crazy. I would be running around this room like I don't even know, but I wouldn't be happy sitting at a desk all day. So for me, it made sense to be in a plant. A lot of the day I'm in fire retardant coveralls, so one-piece coverall, steel-toe boots, hard hat, safety glasses, earplugs, leather gloves. That's what you wear when you go outside. When it's cold, you layer up and you wear some coats to keep you warm. But to me, it's nice to have that balance or that dynamic between the office and the field. But there are roles within engineering where you don't have to do that as well. So keep that in mind.
Did you have any prior manufacturing experience with like 5S or 6 Sigma or any of that?
So I did have a little bit of 5S experience and 6 Sigma, I would say. I did an internship, which I got through Union Career Services Center for a company called Pacific Scientific. They were in Chandler, Arizona, and they made explosives, essentially, for Raytheon and a lot of government applications. And that was a manufacturing facility out in the Midwest. So I did get some exposure, and that's where I did learn about 5S. And our company is very into 5S, by the way, to the point where the plant manager comes around in our cubes and offices and makes sure things are in working order. But we definitely have a strong emphasis for keeping a neat, clean, organized manufacturing plant as well. Things are color-coded, they're labeled. We use certain paint colors. For instance, we'll use white underneath the bases of pump skids or compressor skids so that we can easily identify an oil leak should one arise and correct it. So we have all those types of best practices in place to be able to quickly mitigate any issues that come up. But yeah, I did get some 5S exposure, and I'm glad that you know what that is and are privy to that, because especially when you're working in a manufacturing facility, good companies want to emphasize those types of things.
And you mentioned sustainability efforts, bioplastics, and if I'm not mistaken, all your end products are recyclable. So more out of curiosity than anything else, does Breskem have any recycling plants or recycling initiatives for end-user product plastics, or is that just another industry altogether?
We don't have any recycling plants, and we're not directly linked with any in the U.S. that I'm aware of. But we do have recycling within our own facilities and strongly, recommend that. And any waste plastic, so this is plastic, I'm talking about that falls onto the ground, because we load all of our plastic via rail car. So from time to time you'll have some spillages and overages of the rail car, so you'll have plastic pellets on the ground. We have a third-party company come in and suck up all that material via vacuum, and then that goes, that actually, the payment for that is them being able to come in and clean the plastic up. And then they take that plastic and they melt it down and they turn it into various products as well. So nothing goes wasted. But yeah, as far as recycling, within the plants, we promote that, and we have recycling bins around. And then we have different educational seminars on the numbers to look for underneath of bottles and jars and things like that to know how to recycle those items. So that's kind of the extent of recycling here in the US. I can't speak for Brazil, I'm sure, but we definitely emphasize recycling. We're not about just because we make plastic, let's just go throw plastic bottles, in the trash can. We want to be sustainable, and we want to be, a good neighbor, a good partner in our community, so it doesn't make sense to not recycle.
What was the most interesting problem you've had to deal with? Like an engineering issue?
Most interesting problem. So this one's a little bit, what was interesting about this project, there was one particular project where I was assigned to decrease the amount of dust within the extruder building. So when we're talking about dust, we're talking about all the different resins and additives that go into the resin. So it can be a dusty place if you have leaks, if you have things open that shouldn't be open. So what I was tasked to do was to go around and identify opportunities to decrease dust in our extruder buildings. We have 2 of them. There are 4 stories each. And what I really liked about that project was it allowed me to look for things that you're not necessarily looking for at every day. So, for instance, we have a large silo that the plastic pellets get conveyed through via pneumatics, through air, before they go through a rotary feeder that then takes them to our rail car storage area where they get loaded into rail cars, finishing and handling unit. And the silo had an open vent on top, right? Because it needs to be able to vent because it is under a little bit, tiny bit of positive pressure. But small dust particles were coming out of it. And even though, you had to look closely to see these dust particles because it's not this stream of dust, but over time that accumulates and it adds up. And the reason why dust is so significant is you can have dust explosions, any type of ignition source you have, if there's dust in the area, you can have a huge safety issue. And in fact, unfortunately, there's been many incidents in the U.S. that have underwent dust explosions causing personal injuries and even death. So it's a major concern. And all I did for that one was add a flexible hose on top of that vent, brought it down to a 30-gallon container where I added a vent on top of that, a vent that had a filter on it so as to not allow the dust to escape. And then we just put a PM in place that changes filter out, once a month. And that alone caused a lot less dust being in the building. That was one opportunity. Another opportunity, we would leave this, it was called a master mix blender. It's a large ribbon blender that blends the additives with the resin as it comes from the reactor, the resin that's made in the reactor, and the additives that we put in by hand. Operations puts the additives in to make the mix. But for whatever reason, we were getting dust out of it. And the type of gasket that we were using around the top of the mixer hadn't been changed in a long time. It was cracking, and it was actually becoming hard and brittle, and it wasn't a good application. It wasn't keeping all the dust in, point blank. And I was able to work with a vendor to get a better type of gasketing in, because believe it or not, in case you don't know this already, there's so many different types of gasketing out there. It's unbelievable the different materials we have these days. And I was able to come up with something that was able to maintain a good seal around the top of that mixer. And it's a small thing, but it attributed to pounds and pounds of dust, not coming from that blender, in a year's time. So that was another one. Another opportunity identified, we had straight rope packing, which is, a lot of days you're using mechanical seals on a lot of rotating equipment to keep whatever the process fluid, or solid is inside the machine. And the old school way, or before we had mechanical seals, we had packing. And there's all different types of packing too. It's unbelievable. But we had this one blender. It's called the continuous blender, and it would constantly leak on the drive end through the packing. So through the shaft, there's what's called a packing gland, and then the packing goes inside that packing gland, and that prevents the powder from going out even as the shaft is rotating. And every now and again, you have to push down on the packing using, they usually call it followers, to compress the packing even further as time goes on, so as to not get leaks. Because you'll see a leak and then you'll push the packing in, the leak will stop for a little bit, it'll start again, it'll push the packing in. So packing is kind of archaic now for a lot of applications. But anyway, what I did is I looked in the OEM manual for this blender, and I found that in addition to having packing, there was also an option to put in a purge and use, what's it called now? I forget. It's basically a ring that has holes in it to allow the gas to go different directions. In this case, the gas was air. So to keep a bigger positive pressure in that packing gland than what's in the blender on the process side, so you're not allowing air to escape. So all I had to do was hook up an air supply to this packing gland. You still have packing in there, but now you're keeping a positive pressure inside the packing gland. And by just putting 1 to 2 inches water column on this packing gland, you're able to keep powder. And for whatever reason, we hadn't done it, we hadn't looked at it, right, because we've kind of just lived with the nuisance. Brushed up the powder in a dustpan and called it a day. So that was another opportunity I identified. So that was probably, that's 3. There's a few other smaller projects that were part of that. But at the end of the day, when you add up all the pounds of powder, by doing those small improvements, and that's what I'm talking about, looking for those small improvements first, I think it's really important when you're an engineer, because you're not going to get that $5 million project to work on probably as your first assignment. But if you could prove that you can find these small improvement opportunities and act on them and show the positive difference they're making, it adds up and it does make a difference. And I'd say that's one of the coolest projects I focus on, because although it was all these small little things, it added up to make a big difference. So I really enjoyed that. And I got to work, with operations and maintenance, asking, hey, what are your pet peeves? Where do you see powder leaking out of? Because they have their eyes on the process unit all the time. So got to interface with a lot of different people. So that was a really cool project.
All right. There are no other questions.
Keep them coming.
What happens after 24 months? How are you placed into your final position?
Yep. So it's based on your individual preferences and business needs, right? So you'll be having discussions throughout for 24 months of what you like, what you don't like with your leader, with your mentor, and at the end of the 24 months, it's not going to be a shock as to, or it shouldn't be a shock as to what you liked and what you haven't liked, and where you may see yourself, where you would like to see yourself end up. So it just depends on what your preferences are, what your experiences have been, and also the business needs. Do we have a position open at this facility that you would like? Can we take on this other engineer in this department at this time? So it's kind of working together with both your leader, your P&O person that's assigned to you, and helping you manage your rotations and whatnot. So it's a combination of that along with what you've liked.
Just out of curiosity, how does the 2 screws work in that extruder instead of a dual screw extruder, I think?
Yes, so we have,
I've only seen ones with one screw, so I was wondering where the second one was.
yes, so the 2 screws create more shear. And there's a whole, I mean, there is such a science around screw conveying and extrusion that I am nowhere near an expert or would never, could not talk deeply about this subject, but there are single screw extruders as well, but we use a double screw, and because we need so much, because so much shear takes place, and there's so much mechanical shear going on. We have a 5,000 horsepower motor that then is connected to a large gearbox to get the torque we need to be able to drive these 2 screws. And you have the hopper over one end of the extruder where the resin's falling down right into the screw conveyor. And along the length of those screws, you have different, I'm going to call them blocks. They're actually, we use a spline design. So there's 2 spline shafts, and on the spline shaft you put a block of a certain pattern. So when I say a block, I mean, we actually call them elements, block elements that slide onto the shaft to create the temperature that you want and the shear you want at that location on the length of the extruder, if that makes sense. So if you look at the overall screw, it's not going to look uniform throughout the entire screw. We have different kneading blocks, they're called. We use a German company that helps us with the design based on the products you're running, what your screw should look like in terms of what blocks you should put on there and what's happening at each stage as the plastic travels down the extruder. But basically, you're getting all this heat, all this pressure, all this shear, and then it comes to a point where it goes through what's called a melt pump. And the melt pump brings even more shear and pressure to the plastic, where it finally pushes it through that die plate. This die plate has like 1,028 holes on it, right? And you know, you can do the math, but you're spinning, you know, anywhere from maybe 40 RPM to 100 RPM. So that's how many plastic pellets you're cutting a minute. It's an extraordinary amount. And then after that, like I said, those plastic pellets are underneath, they're in water, essentially. It's an underwater pelletizer. And then the water carries those pellets out to a dryer. And then the pellets get dewatered and dried. And you know, then they get sent on to other conveying. So I kind of went a little bit past the extruder, but that's really all I can tell you about the extruder itself. We use steam heat on the extruder. Some use oil heat toward the downstream end where the die plate is to keep everything hot and molten. But the extruder itself is a pretty amazing piece of machinery.
All right. So let's give a nice big applause. Now, we typically have a case to present, but there are some technical difficulties that didn't allow for it. So we'd like to present you with a rock green pencil.
Thank
for
you.
coming here tonight.
Thank you, I appreciate it.
All right, one more round of applause.
Thank you very much for having me, I appreciate it. It's been nice talking with you.